makes the presentation today the more significant. But with those few words, colleagues, allow me now to hand over to Mr. Edward Matabane, who would tell us more about our guest presenter, Prof. Raju. Thank you very much, and over to you, Mr. Edward Matabane. Thank you, colleagues.
Thank you very much, Chair and delegates and colleagues. My name is Edward, as introduced, and I've been honored to introduce our guest speaker for today. Professor Chandrakanth Raju is a computer scientist, mathematician, physicist, educator, and a polymath. He holds a Master of Science in Mathematics from Mumbai University. In 1980, Professor C.K. Raju received Doctor of Philosophy from the Indian Statistical Institute. He initially taught and researched in formal mathematics and its application to general relativity and quantum field theory for several years. Later, Prof. Raju joined the CDEC to play a key role in building the first Indian supercomputer pattern. He was responsible for putting applications of national importance, and that experience led him to abandon formal mathematics. Over the last decade, as part of the multi-varsity movement, Prof. Raju developed and taught several decolonized courses, including on calculus, geometry, statistics, and the history and philosophy of science. In that period, Prof. Raju proposed a new philosophy for teaching mathematics called the zeroism, and compiled evidence for the origin and development of calculus in India and its transmission to Europe. In his evidence, Professor Raju argued that the claim that Newton and Leibniz developed calculus is far from the truth. His books include: 1, Is Science Western in Origin? 2, Ending Academic Imperialism, and 3, Euclid and Jesus. His books have been highly praised, and his several articles have drawn high praise from both referees and readers. C.K. Raju has long been a professor in various departments, including Professor of Mathematics, Computer Science, and Humanities in universities in India and other countries. He headed the largest computer science department in India, with over 38,000 students. C.K. Raju is an honorary professor of the Indian Institute of Education. He was a Tagore Fellow at the Indian Institute of Advanced Study and served on the editorial board of Journal of Indian Council of Philosophical Research. C.K. Raju lectured on at least 6 continents, ranging from the prominent universities MIT, ICMC in Brazil, University of Cape Town, UNISA, Australia National University, National University of Singapore, and refugees camps in Palestine, and a remote village in schools in India. Prof. Raju also interacts with non-academics, as in his conversation with Dalai Lama or with artists at the music festival in Berlin. He has received numerous honors and awards, including the TGA Award in Hungary in 2010 for correcting Albert Einstein's mistakes. Ladies and gentlemen, allow me to welcome Professor Raju on stage. Thank you.
Yeah. Thank you. Am I visible and audible?
Yes, yes, Prof, you are.
I'm visible and audible, and my screen is showing. The presentation is showing.
It is showing now, Prof.
It is showing now. All right. So thank you again. Thank you very much. I'm really very happy that you suggested this topic of revolutionizing education. So let us get on with it, because it's quite a big presentation, and I will just skim through it. I will not necessarily go through all the references. The idea is that I will keep it, post it online, so anybody who wants to go into it in more details can do so at a later time. So this would be just a sort of guided tour because it's a vast area that has to be covered. All right. So the first thing I want to about the talk. That was not exactly my suggestion, but there is. It is the truth. I mean, in South Africa, you had a revolution 3 decades ago, and that revolution asserted the truth that whites are not superior. And I am asserting the related truth that white Western math is not superior. So you need this revolution 2.0 to fully emerge from the residual grip of white Western domination. So, as I said, I want to first of all explain to you why Europeans were inferior in math and the kind of blunders they made. See, they did not have even elementary arithmetic properly. They had some Roman arithmetic, but it was quite primitive. And therefore, they imported their elementary math. And the key point I want to make is that they had difficulties in understanding the math they imported. And therefore, they made blunders. Europeans themselves abandoned their native Roman arithmetic because it was very bad. And they adopted what they call Arabic numerals or algorithms from the Latin name of Al-Khwarizmi, who wrote Hisab al-Hind, that is Indian arithmetic. And the lack of understanding is clear from the very terms such as zero. So zero, as you know, is this second screen visible?
Yes, it is, Prof.
You can see zero?
Yeah, we can see zero.
Okay, so this is from the Arabic Sifra, as this Oxford English Dictionary tells us. And Sifra or cipher, as it is called, means mysterious code, all right, a secret code. So what is mysterious? Roman arithmetic was additive, like coins or counters, pebble arithmetic. And the West did not understand it, and therefore they passed a law against zero, Florentine law against zero in 1299. Now, zero relates to negative numbers. So 9 minus 9 is 0. But Roman arithmetic had no negative numbers. So you're dealing with pebble arithmetic. There's no such thing as a negative pebble. So Europeans were confused about negative numbers. From the time of Fibonacci, I'm leaving out Gerbert, from the time of Fibonacci's Liber Abaci to Augustus De Morgan. And somebody understood, somebody did not. De Morgan did not understand. So he was a very influential professor from University College London, and he declared negative numbers impossible. So this is, are you able to see this? Are you able to see this separate slide?
Yes, we can see the order of additions.
Okay, fine. Thank you very much. Now I am persuaded that this is working all right. So you see, he says such a stupid thing. He says that 10 minus 20 plus 50 is impossible. All right, you can have 10 plus 50 minus 20 because negative numbers are impossible. So this is what De Morgan said. And this he is writing in the 19th century. And he is a very influential professor of mathematics. In fact, he went a step further. See, in 1898, he said that belief in witches, he said student must reject the definition that minus a is less than 0. It is less than nothing. And he said it is astonishing that the human intellect should ever have tolerated such an absurdity. And they should have outlived the belief in judicial astrology and the existence of witches, either of which is 10,000 times more possible. So this is Augustus De Morgan talking about negative numbers. So if you were right, you should stop teaching negative numbers in school. But my point is that he did not understand negative numbers because negative numbers were an import, and therefore he muffed them because he tried to correlate it with his own cultural understanding of numbers as counters, coins, and so on, pebbles. So algebra was imported from Al-Khwarizmi, his book Algebra wal Muqabla. Muqabla is a contest, which is like an equation. So he used it to solve equations, and he translated the work of Brahmagupta on polynomials and solved linear. Brahmagupta solved quadratic equations also. Al-Khwarizmi was limited to linear equations. Now you have the word surd. The word surd, according to the Oxford English Dictionary, this is from the unabridged Oxford English Dictionary, it means deaf, surdus, deaf. Now why square root of 2 deaf? I mean, it's a bit amazing that it is deaf. And why do you call it deaf? So the point is that in the Indian Shulba Sutra, you have square root of 2 is the diagonal of a unit square. If you have a unit square, you draw the diagonal, it is square root of 2. But the word karna also means ear. Ear. So bad karna was translated as bad ear, which is deaf. So it goes on like that. These are the kind of blunders that Europeans made about the most elementary mathematics imaginable. Negative numbers, square roots, sine. The word sine is from the, again, I'll give you the Oxford English Dictionary. The word sine is from the word jabe. This is jabe, my pocket. All right. And what has it got to do with pockets? Because it is from the Sanskrit term for it is ardhaja, the half chord, and jiva. So jiva was rendered in Arabic as jiba because there is no v sound in Arabic. And the Toledo translators, you see, it was written as just the consonantal skeleton j and b, like you do pleased in SMS, just PLS, just leave out the vowels. So the word jabe was used, and they translated it as sinus, hold, and therefore sine. We are still using it. And the point is, you're not just using it, there is a conceptual error. The very word trigonometry says it is about triangles, but actually it is about circles. So I asked this question in my test. So in pre-test, this is my pre-test for my calculus without limits course. So I asked students to define sine of x. They will say opposite side by hypotenuse. Then I asked them what is sine of 92 degrees. So you can't have a 92-degree angle in a right angle triangle. So they don't know what to do. And I said, you don't know, but my calculator knows. So my calculator tells me that sine of 92 degrees is this much. So they don't know, and they have got a conceptual error about what the meaning of the sine function is. So this is the kind of thing that happens because this is how the West learned it. This is why the West calls it trigonometry. In India, the sine is always in the chapter of the circle. So I can go on like that. So this, I have an article here. It's a link to it. It has got a lot more details on pre-colonial appropriations of Indian Ganit, epistemic lessons. It's about probability also and so on. I won't go into it. Please check it out later after I put it up. This is available on the net. So that's enough of jokes. Let's get down to business. And let's go to the issue of transforming education. Why do we need to do it? I think that's fairly clear. Mathematics is regarded as a difficult subject across the world. And most recently, the California State Board canceled the calculus in schools because US school kids find it difficult. And it aimed to switch. I'm not giving you the link. I can't go through all of them. I'll just skim myself. Right? They said we want to do data science because that is needed for AI and big data. And that is expected to be the key technology for the 21st century. Now, my response was that a proper understanding of statistics requires calculus. And if you don't have a proper understanding of statistics, all right, this article is here. If you don't have a proper understanding of statistics, then you will end up making very bad bots. You know, you'll see ChatGPT, but any kind of bot, if the person who's programming it does not understand statistics, it's run bad bots, and you'll rely on bots, and that can be very, very dangerous for the future. So the better thing is that people, you must make math easy, especially calculus, and give people a proper understanding of calculus. The solution is not to dumb it down as the California State Board has done. So what is the way out? How to make it easy? So this was suggested by my research on the real history and a better philosophy of calculus, which began some 25 years ago. So this is an article in the which you can take a look at in Philosophy East and West. It's a longish article. Of course, I can't go through it. I'm just showing you where it is. And there is my book, fact book of this is the fact book, Cultural Foundations of Mathematics. Maybe I go to the next place where you can read it better. Nature of Mathematical Proof and the Transmission of Calculus from India to Europe in the 16th century. So claim is that the book argues out this claim. It's a very big book and I can't summarize it. I will try to summarize it, but you have to go through it. Okay. So the point I'm making is obviously that calculus is not of Western origin. Newton and Leibniz did not discover the calculus. That is false history. Actually, West stole calculus. And briefly, Indians developed calculus from the 5th century onwards to derive precise trigonometric values. How precise? This is how precise. So these values, as you can see, are highly precise. And the Europeans wanted it. Jesuits based in Cochin, Kerala, they collected these texts and sent it back to Europe because precise trigonometric values were needed for the European navigational problem. So I have a long article on that, on Marx and mathematics, what this European navigational problem was. Once more, I'll just skip through it. It was the biggest scientific challenge facing Europe from 16th to 18th century. In the 18th century, British Parliament passed a law creating a board of longitude. They didn't know, they acknowledged. And I'm saying stolen. Why not transmitted? Earlier I said transmitted, I was being polite. Because the West did not acknowledge the true origins of calculus and still does not. Why not? Because the claim of discovery of calculus is critical to boast of Western superiority in math and science. All right, so we are about education. What difference does it make if the West stole it? What difference does it make to calculus teaching? So first thing you have to understand is that people steal knowledge because they are inferior knowledge. I mean, students who cheat in an exam do so because they have an inferior knowledge and they always deny. They claim we did it on our own. So as a university teacher, I could not really invigilate in such a big class. So I had developed a technique to catch thieves after that. And that is my epistemic test. That even after they have stolen the knowledge thieves fail to understand what they steal. This is a very critical point. Those who steal knowledge fail to unable to, if you ask them questions, what have you written here, what does this mean, and so on, then they fumble. And that lack of understanding is proof that they stole or that they made dependent rediscovery. So I applied this to history. You can't interrogate the past. I can't go and ask Newton some questions and so on. But circumstances are already very suspicious. Calculus took 1,000 years to develop in India from the 5th century to the 16th century, but came overnight in Europe, right? They didn't have fractions until 1572. And fractions were known to Egyptians and Indians from at least 3,000 years earlier. But Europe did not have. How do we know? Because the Gregorian calendar reform of 1582, Clavius introduced fractions in the Jesuit syllabus in 1572. And he was the person who did the Gregorian calendar reform, but he did not have fractions. It has leap years. You still have that same calendar. You still use leap years. You don't specify the duration of the tropical year in terms of a precise fraction. Therefore, equinox does not come on the same day. So you have leap years. It's a very inferior system and a very complex system. Every 4th year is a leap year, 100th year is not, 1,000th year is, and so on. So I will, you can take a look. I will skip this Shakespeare quote. So Europeans fail to understand calculus. That's the point, because they stole it. That's why I'm talking about theft. So this suspicious, very suddenly they don't know fractions in 1582. By mid 17th century, they already have less than 100 years. They claim to have got calculus. So suspicious, but not true. So I developed proof in my book, which was because theft is a criminal offense. So the motivation, the European navigational problem, you want to determine loxodromes, latitude, longitude, and for that you need the radius of the Earth, and therefore you need trigonometric values for all that. How you use it is explained in my school text. It's very easy stuff. There is circumstantial evidence. For example, Fermat's challenge problem to European mathematicians, which could not be solved by any mathematician in Europe. It is a solved exercise in Bhaskar 2, of course, all independent rediscovery. And see what happens. Let me just show you this challenge problem for a minute, because it's something important. So if you see here, it is a solution of an equation. All right, the equation is nx squared plus 1 equal to y squared. But the solution, look at the numbers. 226153980 and 17663190049. Just by accident, they were the same. Verma did not know about the Indian text, where the Jesuits were there, but they were transmitting Indian text. He gave the same thing, but they claim we did not know. You think you will let a student off like that? Such big numbers, how can there be accidental rediscovery? It is theft. All right. And there is, of course, documentary evidence, like Matteo Ricci's handwritten letter that he is in Cochin. This is from 1582, this handwritten letter, which he is looking for an intelligent Brahmin or honorable mood to tell him about the methods of timekeeping, chronicles los tiempos. Okay. So I'll skip that because we are not into history, we are into education. All right, we are into education, but West has not admitted type of calculus. Therefore, in my book, 2007 book, I applied epistemic test and said this is proof that West stole the calculus because it did not understand. So what aspect of calculus exactly did the West fail to understand? There are two key aspects. One is how to do an infinite sum. The second is what is the exact definition of derivative. Newton used calculus, he had to define derivative. How did he define it? And he had a series which he called Newton series or Leibniz series, and it involves an infinite sum. How do you do that infinite sum? So this was needed, I already told you, because precise trigonometric values were derived in India using infinite series for sine and cosine. I'll just flash them to you for a minute. This is the Sanskrit slope which you find, and this is its mathematical English translation, and this is the mathematical translation. So if you check it out, it gives you what is today called the Taylor series for the sine function. Similar slope for cosine function, and this is the translation. And if you translate it mathematically, it gives you the so-called Taylor series for cosine. And similarly, you have for the arctangent function. So if you look at the arctangent function, you have this sort of series. This is the Sanskrit slope for it, which is the Leibniz. He independently rediscovered it, right? He got it independently. The texts were coming from India to Europe, and somehow he got the same answer exactly. And then there is this arctangent series, which is very famous and which is well known, which is important for determining the value of pi. And of course, there were rapidly convergent expansions and so on. I won't go into those details. They are there in my book. All right. So we have this point I'm making is they did not know how to sum infinite series. Indians did. They summed an infinite series. Now, this is there in my Springer encyclopedia article. That is what I'm showing. And the sum of an infinite, the word infinite is used, anantya. And this is given. You have the usual formula. And the point is the West got the formula and didn't get anything else. Now, this is an infinite series. So Egyptians knew finite geometric series for a long time. If you see the I of Horus fraction. All right, beautiful fraction. And you find this in in Luxor and so on. So this is geometric series. It's a finite geometric series. But I'm talking about infinite geometric series now. Finite geometric series known for a very long time. Find it also in the Veds and so on. So West got the formula for the infinite geometric series, but failed to understand. So Descartes said, how do you sum an infinite series? He said, beyond the capacity of the human mind. All right. That's Descartes, the big philosopher. Galileo, who had access to Jesuit text sources from Collegio Romano, he concurred with Descartes. This is in his letters. which are cited in my book, and left calculus to his student Kimberley. And what did Newton do? He defined derivatives using silly fractions. How silly are fractions? You never use them. So this is again there in Marx and Mathematics, part 4, epistemic test. All right. So you don't use fractions. Nobody knows what fractions are. Nobody knew then and nobody knows now. But he used the term fractions. And the West acknowledged this difficulty. It's not I who am saying their difficulty. West acknowledged it. Berkeley acknowledged it. Karl Marx acknowledged it. They acknowledged that fractions are incomprehensible. Berkeley had this famous polemic. They are ghosts of departed quantities. So this was acknowledged. Now you can say Karl Marx was not a mathematician. Berkeley was not a mathematician, but the mathematician Dedekind recognized, he said what we are teaching in calculus is nonsense. So he proposed real numbers at the end of the 19th century. And he said real numbers are a better way to understand calculus. And today, all calculus texts, including, let us say, the Indian class 11 text, they start with limits and derivatives. So if you want to define a derivative, you have to define limit, but they can't define the limit. I'll just tell you in a minute why not. So everything, infinite sum is defined as a limit, derivative is defined as a limit, integral is defined as a limit, even functions, say exponential function, infinite series, sine function, infinite series, so it's defined as a limit. Everything needs a limit. And for limits, you need real numbers. Because if you take a sequence of partial sums, such as if you have an algorithm for square root of 2, you get the sequence of partial sums, you cannot converge because square root of 2 is not a rational number. I think everybody here knows that. So I don't need to go into it. Okay, how am I doing for time? Okay, not so well. So Newton and Leibniz could not have understood calculus because today we teach that real numbers are essential for calculus, but they came 2 centuries after Newton. So now real numbers, the point is limits need real numbers. And these are omitted from the usual fat calculus text. So I won't go into this since I'm running short of time. Thomas calculus, as you know, they are run into thousands of pages and they are covered only in advanced calculus or in linear analysis. And I used to teach that and advanced functional analysis in Pune University for years. So even these advanced courses omit an essential part. They don't define real numbers because to define real numbers, you need set theory. Now, this is a set of transparencies that I've got. Now, I don't think I can explain it because each of them will take a separate lecture. The point is that it is a super task. Summing an infinite series is a super task. It involves a metaphysics or a fantasy of infinity. And which formal mathematicians are very happy because it turns them into Superman, as in Superman fantasy. So point is not a single student can define. If I go back to my pre-test, not a single student can define what is a set. And if they define, they try using some naive set theory or Cantorian set theory. They can't explain how to resolve Russell's paradox. So they have no consequence. They have no understanding of what they are doing in terms of real numbers because they don't know set theory. All right. And set theory developed, axiomatic set theory developed only in mid-20th century. So this is not taught to calculus students. Even professional mathematicians don't know. Very few know. So most people just blabber real numbers, limits without understanding what a real number really is. Involves a huge metaphysics of infinity. So I issued a challenge to the mathematician with whom I discussed in Cape Town. Just prove 1 + 1 = 2. Nothing more than that. 1 + 1 = 2. He's a senior mathematician. He's retired now. Just asked him to prove 1 + 1 = 2, direct from the axioms of set theory. So he blundered. He said use Peano's axioms. But in formal mathematics, the real number 1 and the natural number 1 are completely different entities. So it was a blunder. Peano's axioms don't apply to real numbers. Axioms of set theories do. And he did not know the axioms of set theory because of the professional mathematician. You don't need it most of the time. Then in JNU, I offered this with a price of rupees. There is a video on that. Okay, this link goes to the video. So this is the video with the Vice Chancellor sitting there. I gave this challenge also in the Indian Army. So to anybody who could prove it, I offered a prize of $12,000. That's 10 lakh rupees approximately. just to show how difficult a proper understanding of the theory of real numbers is. You don't know 1 plus 1 equal to 2. But you trust, you learn to trust. Okay, this chap has done it, trust him. Why should I trust? What is mathematics about? Trusting the West? Certainly not. I cannot accept it. And their fantasy about infinity? Certainly not. So, only point I'm making is that the solution which was invented by the West to understand calculus is so hard that nobody understands anything about it. All right, they stole, they did not understand, but they developed an excessively complicated way to understand, which cannot be taught, is not taught, but is socially approved as the correct way to teach calculus, real numbers and limits. All right. Now, did it add practical value? No. They added political value for themselves, and imposed this understanding through colonial education, but they did not add any practical value. Why not? Okay, this is the point I'm making. So Newton, how did Newton get practical value without real numbers? He did some theory of gravitation and so on. So he did not need real numbers. Because the exact value of a real number, you can't write down. It will take you an infinite amount of time. So you have to work with rational numbers. You don't have real numbers. Computers can't use it. See, for every practical problem today, supposing I want to send a rocket to the moon, I want to calculate the rocket trajectory. I do it using floating point numbers. So I have these are from my class lectures in C. What is the floating point number? So here's the limit. You can just go into that if you like. Point is a computer has finite memory, and therefore it uses they use base 2 or whatever you like, doesn't matter. It cannot use real numbers because they're a fantasy, and a computer can't share that fantasy. So every practical application today that is done on computers, every application is and can be done without real numbers. So real numbers add nothing to practical value, but they add enormously to the difficulty of calculus. So this is the key lesson I learned as part of the CDAC team, because I was supposed to implement applications of national importance, oil and including rocket trajectories and so on. But you could all do that without real numbers because I came from a formal mathematics background, partial differential equations, so easy to solve on a computer. So West did not discover calculus, but it did invent the present day difficulties of calculus. And these math difficulties are a source of power for the West, because what will you do for set theory? You will ask the West. What will you do for real numbers? You'll ask the West. Oh, here is a chap who's in position of authority. He will know. Let's ask him. Let's trust him. Even for 1 plus 1 equal to 2. So you are reduced to a miserable state of epistemic dependence. Total epistemic dependence for the simplest thing like 1 plus 1 equal to 2. All right. And it was a colonial imposition. We know that they were in power throughout the world, and they colonized and they introduced colonial education, and they said what we do is superior. This is the superior way of doing it, so you must imitate it. And because of that colonial education, we believe it is superior to imitate the West, and we are plagued by those difficulties, and therefore people don't learn. So that's the point that we want to address. And I say superstition because we are terrified of trying something different. I've been talking about this for some time. I've tried it elsewhere. I talked about it in South Africa. I said that why don't you at least try, have a trial course and see if you like it. But they are afraid because it's a taboo. All right, you say, ask a formal Western certified formal mathematician. He'll say no. Like Oliver Twist, you're standing there and saying, please, sir, can we try teaching calculus differently? And he said, no. So that's mental slavery. It's a trap from there is no exit. And that is what we want to exit. If you want to exit, you need a revolution in mathematics. So what I thought was a little bit different. Okay, this is all right. I based myself on the Indian calculus because my thinking was that whosoever invented the calculus had to have done it in a simpler way. And that is the way it should be taught. Okay, so I had been a formal mathematician. I was teaching functional analysis and so on. I didn't feel the need to ask anybody about calculus. I taught advanced calculus and so on. So simple way must have been understood by the real inventors. And that's what I said I should try. So I said it can be made easy by teaching calculus that way. And therefore, I said, I'm not going to imitate the West. Let us try it. And I'm not just talking about teaching. I'm talking about the entire Western philosophy of math, which is formal math and axiomatic math. I'm saying reject it entirely, not just real numbers and calculus is just one example. I'm saying reject the entire philosophy because it does nothing except to give power to the West and add difficulties, add metaphysics, which has no practical value. So to implement that, you have to approve the rhetoric of Western superiority in math, because unless you approve that, you can't change anything. But I realized that later. Initially, I just wanted to establish an alternative curriculum and a teaching method. So I tried my calculus teaching experiments with 8 groups. This included one postgraduate group because of postgraduate essay, because the questions that were asked for them, pre-test questions were different. They were, this was done in 3 countries, India, Malaysia, Iran, at the Central University of Tibetan Studies. This was the first place where I started in 2009, Calculus Without Limits. And then there were 4 groups. There are reports of that which have been published long time back. There's a video on Goodbye Euclid. Once more, I think if I have to keep to time, I will just skip it. Ambedkar University, Delhi. This was the social science students. They were very happy. Just tried out here. Postgraduate thing in Tehran. Just tried out here, and so on. Just tried out in another university, SDT University, the science and engineering students. So they are here in the computer lab, a big batch. All right. They were delighted at how easy the real calculus is. Because they all go science and engineering, they go through the IIT test, they are mugging how to calculate derivatives and integrals. This was not difficult here, what they did. So I also explained it in Western universities, including my talk at MIT. So this is the talk at MIT. There is a video of that. Okay, so take a look. And there are lots of articles in the Springer Encyclopedia. I will not go through all of them. It's on zeroism, on logic, on calculus transmission, on probability. And you have open access here because this encyclopedia is very expensive. It is some 2,000 euros. So you have free access on my website to these articles. And leaving the links here for people to look at later. So for calculus prerequisites, I said you also have to teach geometry differently. You can't teach geometry the way it is taught as Euclidean geometry. Basic difference is that in India, as in Africa, the basic instrument, geometric instrument, is a string, not a compass box. And so I did pedagogical experiments on that in schools. Schools is difficult because the curriculum is slightly state controlled, but it had an alternative philosophy, which is called Rajju Ganit or string geometry. So these experiments are done in Nasik, for example. Here is the school in Nasik. 40 schools were there. It was done in Chamraj Nagar with teachers, students. It was done in Gundlukpet. It was done in Indore. The teachers are learning here how it is to be done and so on. So once again, the students and many teachers were very happy. As one teacher said, how were we teaching this nonsense, which we have taught? You can take a look at my, well, there are many other things. You can, there's a school text, Rajju Ganit, and what was in the workshop was to teach how they teach 5 different types of geometry: Hilbert's synthetic geometry, Birkhoff's axiomatic geometry, Euclidean geometry, compass box geometry, and finally the geometry in the Shilpa Sutra. So all this material is available online. Please go through it. All right. So there's a whole list. There are videos of the workshop. Just flash it to you. So it takes too long to load. So there are 2 videos. Find it in the list of videos. You'll find a more comprehensive reading list here, which is lots of calculus courses, Rajju Ganit courses, statistics courses, history, philosophy of science, where they have been tried, all the material, the books, videos, and so on, popular level articles, scholarly articles, and so on. So probability and statistics, and so on. So once more, I will just skim through it. So I'm leaving this. So these were also part of a political attempt to decolonize, because for 2 centuries, colonial education was entrenched, and Western political control over it was entrenched over mathematical knowledge and over mathematicians. And so that entrenched the superstition that white West are superior. As you saw, they didn't even know basic arithmetic, 3,000 years behind. And this attempt was supported by the Malaysian and Iranian press, decolonization, escaping from the clutches of colonization, and there were many people who were involved in this. Similar thing was done, well, just to give you this one is on mathematics. So mathematics made easy, so it was supported by the press. And similar thing in India. Indian press also, some sections have supported it. So for example, there is a long interview, can't go into that, but there was support because it's a political activity as well, not just a pure mathematical activity. All right. So South African responses were a bit different. Not everywhere. I'm just saying that I'm talking only about some responses were very good, but some responses, particularly from the University of Cape Town, were very bad, and from the South African press. Okay. So when I first visited South Africa in 2016, there was a Rhodes Must Fall agitation going on here. And there was a lot of talk of decolonization and so on. And so I thought I can share my experiences. And so I wrote an article in The Conversation summarizing this. It was published, it went viral, and was reproduced worldwide. But then it was censored and taken down, except in Science 2.0 and Wire, which took it down and put it back. So this is an example of global Western political control over mathematical knowledge. Why? Because if there's something wrong with the article, they should have pointed it out. But the article was published in its entirety in the Journal of Black Studies. All right. On academic censorship and the Pythagorean proposition and so on, it is there. And it is a peer-reviewed journal, if that is a standard. Point is, if somebody has something to say against it, they should say instead of just censoring it. And it was published in the Rhodes Must Fall book from Oxford. So why did this article, why did this truth so enrage whites in South Africa? Because it's truth, because they could not contest it. Why were they so enraged? So first I said Euclid was a black woman. Right? This is in my book, Euclid and Jesus. And second thing I said, this statement that what mathematicians did dead white men create. This was in response to an article written by a South African professor, when they were ignorant even of elementary fractions and 3,000 years behind black Egyptians. So they were enraged absolutely, because what is being done here is that I'm attacking the dogma of white Western superiority in math. That is the central dogma. And that is at the core of math teaching. Once you give that up, then everything becomes straightforward. So no one had a valid academic response. I'll return to it later. But if anybody has any objections, please keep them ready. There'll be a question hour and you are welcome to ask. So there was a panel discussion in the University of Cape Town. I don't think I can go through all of this again. It takes a long time to load. Please look at it. The links are there. But there was a racist response to the views of conspiracy theory, Bantuization, and so on. But the point that I was expecting something like that, but what I was surprised by was the stupidity of the lies. So absurd that they lacked prima facie credibility. So Bantuization, they said, the professor from UCT, a student of GFR Ellis, he brazenly lied in the South African press that I'm making math easy by dumbing it down, that Bantuization. And the press never checked back with me for my response. Now, I gave this response in a scholarly article, and I showed my tutorial sheet for my Calculus Without Limits course. Now, the thing about this tutorial sheet is this. What I'm doing here is I'm solving the equation for a simple pendulum, where simple pendulum is the first science experiment that you do in school, first serious science experiment. And the functions I'm using, as you can see, are the Jacobian elliptic functions Sn, Cn, and Dn. And they are being solved. And the students are being asked to do it, and this is a tutorial sheet. It is the first tutorial that the students have in my Calculus Without Limits course. And then after the first tutorial, they're able to do this. And this is not done. And if you do it and do the correct science, then they call it one-to-ization. My God, what sort of, what advanced calculus course. And they are included in my course to show that making math easy enables students to solve harder problems. All right. So maybe I can just give you a demo. You can take a look at my eldest son's school project document, which lists all the details about Jacobian elliptic functions and a simple pendulum. Or you can see my 2005 article. This is time. What is it that it can be measured? Which discusses the theory of the simple pendulum, and or see this thing on brachistochrone and so on. So both the sons have PhDs in physics. But point is brachistochrone resistance, which is a problem he did in school, is not even done at the research level. There's no accepted solution. So anyway, why are Jacobian elliptic functions needed? They are easy to describe. Theory of the pendulum, simplified theory, the Barn-Twice theory, should I call it, which is there in all the school texts, which is there in all the calculus texts, says that the amplitude of the simple pendulum is the time period of the simple pendulum is independent of amplitude, because t is equal to 2 pi root over L by G. But the simplified theory is contrary to observations. Time period of the simple pendulum is dependent on amplitude. But to do that, you have to have Jacobian elliptic functions, which you don't teach. And say, if you teach them, that is wrong. You should not teach correct science. That is what the criticism is. That is how lacking in credibility it is. And that is what happens if you trust a formal mathematician. So students and teachers wrongly believe the theory is right. They don't perform the experiment. They don't check with the actual observation, and they get the wrong thing. They trust authority. Misleads. Well, the comparison is very easy. Now I can give the comparison. I don't know if this will work. I have this executable here. I can just show it to you right now by doing it on the spot. So I have Jacobian elliptic function. Are you able to see this? Is this visible?
Yes, Prof. Can see that.
You can see this. All right. So you can compare how bad the theory is by, I will compare it, Jacobian elliptic functions with the corresponding functions sine and cosine. So just sine. Let us take sine. I have a problem in typing. Sine of x. Okay. So this is the difference. Now, if you believe that the blue line is the Jacobian elliptic function, then the red line is sine of x. So the time period is quite different, and the time period will keep varying with the amplitude, and you can check out my son's project for that. The point is, if you use the simple pendulum as a clock, you go in a ship, your ship will sink. It's a matter of life and death. All right. Where am I? Okay. Now, is my presentation visible?
Yes, Prof.
Sorry.
Okay. Yes, Prof.
Yeah. Okay. All right. I get worried. Otherwise I'll just keep talking and it won't make sense. All right. So it's astonishing that such a brazen lie by a math professor from UCT is accepted, because I am what? Just a brown man from somewhere. Why should you believe me? All right. But point is, even a person sympathetic to me, he wrote an article and he believed that they were right. He said, okay, this guy is not a mathematician, he's just a historian of math. It is there in the Daily Maverick. And he said, you must discuss, you must have an academic response and so on, you must have your perspectives. So he's very sympathetic, but he believed that there must be at least 1% true what they are saying. It is not. 100% lie. People don't expect that, but that's what it is. Okay. So point is, don't trust a formal university mathematician to help you with decolonization of math. They will only mislead. Because if they accept, their life work will become useless. They accept a change of philosophy. And they know that you're ignorant of math. And so they can fool you with the most brazen lies, teaching Jacobian elliptic functions as Barn-Twiceization. Absurd. I mean, height of absurdity. And so I don't say trust me. I don't say that even to my students. I only give them one formula. Check, check, cross it, check. Because only when you do that, then the knowledge becomes yours. Otherwise, you're just trusting somebody. All right. Then there was this polemic of conspiracy theory. So they started that because they were very worried that I would speak in the math department. And later, a Kenyan reporter, white Kenyan reporter, reported this in an MIT magazine. The general point I'm making is, how do you call an alternative philosophy and pedagogy of math as a conspiracy theory? I mean, can I say that Kant was, the philosopher Immanuel Kant was a great conspiracy theorist? Can I say that Plato was an even greater conspiracy theorist? And how do you call philosophy and pedagogy a conspiracy theory? I mean, it's just, and then make some wild personal attacks and just say, okay, we don't want to discuss because of this. So you may not like it, but if you don't like this new philosophy of math, that's perfectly all right. Then you have to contest it. And the whole point of conspiracy theory is that you avoid contesting it. Now I'm not doing very well for time, so I will skip the next slide. Okay. So, okay, let us skip this. Point is that they don't like my critic, and they don't have any moderately credible response even in the last 25 years. Okay, so I will skip this entirely because I think relating white to Western supremacy is very important, but I have an article on that, which is called Euclid Must Fall, Part 1. It was a keynote I gave at Tübingen and Pretoria. And so let me skip this because point is how to, okay, maybe I should just take, oh, never mind, I skipped it. You have to put that dogma of Western supremacy on the table and discuss it. And unless you discuss it, you cannot fight it. So the important thing is that formal math prohibits facts and says that is superior and calls it reasoning. All right. So you put it on the table, and once you put that supremacist dogma on the table and make it open to academic discussion, and once you force the discussion, I think half the battle is won. So let's take a claim from the class 9 Indian school text. It says Greeks did geometry in a way which was superior to all others. So it says Babylon, they did very geometry practical. In India, Rome, and Egyptians mainly consisted of statements of results. And they used geometry only for practical purpose and did not develop it as a systematic science. These chaps coming so many thousands of years later. So now they say in civilizations like Greece, the emphasis was on reasoning. Sounds plausible to the student. The Greeks were interested in establishing the truth of the statements they discovered by using deductive reasoning. Appendix 1 is about mathematical proof. All right. So everybody else, the whole world was inferior. What they did in geometry was inferior. Greeks did something superior, and that is what the West does. Right? That's the point. Whole point of the Euclid story is to assert that Greeks did a superior math, which the West does today, and which us ought to imitate. The first point to note, very important point, which people forget. If you have a superior and an inferior math, there must be at least two types of math. Very important. Don't confound it one with the other. That's standard sophistry I'll come to. So formal math is done by the West since 20th century and supposedly done by purported early Greeks. It's not done by any Greeks. Complete nonsense to say that. And normal math is traditionally done by the rest of the world for thousands of years. So there are two types. Why is this formal math superior? So, because they say, okay, it alone uses reasoning. That's just a blatant lie. Right? Deductive reasoning is found in math in the Indian Nyaya Sutra, talks about reasoning as the second means of proof. It just lists 4 means of proofs. All right. Now, this Sanskrit, maybe you don't know. Let me, how these proofs are used. So what are those words? Pratyaksh is empirical proof. And this is an example from math from Ganit 13, Aryabhat. Anuman, which is inference, deductive inference. So Indian proof of Pythagorean theorem and so on. And analogy and Shabd, authority. When you don't know, you ask authority. All right. So those are the 4 means of proof which are listed there. and deductive inference is one of them. All right. And a striking example of the use of deduction in math is the inference by Aryabhat that the earth is round. Round like a kadam flower. This is a kadam flower. So this is 5th century. So he deduces it. He didn't go out to space to see it. And the point is that Greeks did not use math. I'm just quoting from Plato. Sorry, not the Republic directly. I want to. He says, see what he says. I've hardly ever known a mathematician who could reason. So Greeks had reason, but they didn't claim that mathematicians use reasoning. School text claims it. Of course, school text must be right. This is primary source. I have just opened Plato's Republic. You can search for this phrase in Plato's Republic. It's available online. And school text must be right and Plato must be wrong. Original text must be false. So anyway, limited point I'm making is that whether Greeks used reason or not, the fact is that they were not alone in using it. And let's forget what the Greeks did. Let's look at the definition of proof, which is available in any text in mathematical logic. All right. So a proof is a sequence of statements in which each statement is either an axiom or is derived from preceding statements by means of some rules of reasoning. And a theorem is the last sentence of such a proof. All right. So that is the definition of a formal mathematical proof. All right. I have given it here. You use some rule of reasoning like the modus ponens, A implies B, therefore B. All right. But the point is, it's not about reasoning. Because reasoning was used in other cultures. The USP, the striking new point here in the definition of mathematical proof, formal mathematical proof, is that it prohibits the empirical. Let me repeat it. It prohibits the empirical. It's not about use of reasoning. It's about prohibition of the empirical. Use of reasoning, everybody did. Science also does. What is unique to math, formal math, is the prohibition of the empirical. You cannot say, I see this, therefore it is true. I observed this, therefore it is true. So I use the line that formal math is divorced from the empirical. And the Indian class text explains it in a way you must use only logic. Beware of what you see. Now, see, this is what is not explained. It's not use of reasoning, it's prohibition of the empirical. How does that lead to superiority? Okay, so the point is that if you can't even do 1 + 1 = 2, this time in integers. So let's take a concrete example. How do you do 1 + 1 = 2 in normal mathematics, when you accept the proof, empirical proof, as you do in Indian Ganit, for example? So you have simple proof. Any child can understand this. Kindergarten child can understand this. All right. But formal mathematics prohibits this. What do? Rejects the empirical. So now we see that Bertrand Russell gave a big proof in 378 pages. And this is the 378th page. Now I want to know which person here, how many mathematicians here understand what is there in this one line on this page, 378. And then, well, we'll come back to that. Let me keep this open maybe. The point is, what does all that complexity, what use value does it add to 1 + 2 in a grocer's shop? I had a nice cartoon, it's gone. Too bad. But you'll find the cartoon somewhere. The image is not there anyway, gone somewhere. So, same situation for science and technology. Sending a rocket to the moon. What works is normal math. Computer can't do formal math. It does normal math. And formal math adds complexity, but zero use value. And you cannot even write down exactly what a real number such as square root of 2 is. I ask people, write it down, square it, check whether you get exactly 2, not 1.999. So real numbers cannot be used. We went through that. Let me skip that. There is a sophistry that is used here. People say about math, it works. But what is it that works? They use normal math. Normal math works. It has worked for thousands of years. You go, you do your accounts, you do your grocery, you do whatever everyday math. It works. But you confound, when it comes to talking about what works, they confound normal math with formal math. They say math is universal. If it is universal, how can one type of math be superior? But when you ask what the value raised by, added by formal math, they have that thing. But then you want to teach, then you say, okay, you must teach the superior math. If I say traditional math was used everywhere for thousands of years, it must be universal. Say, no, formal math is superior. That's what you should do. Now, this is the kind of silly level paradox which is created. So it's how it works in practice is that when I visited Cape Town University, I visited the Deputy Vice Chancellor, Mama Getty Fucking, and she's now the Vice Chancellor. She asked me this question: mathematics is wrong. Why are bridges still standing? It's a gross misrepresentation of what I say. I'm saying normal math works. And Incas were building bridges from long before formal math. Arabs were building bridges. Your Adelaide of Bath, he went to study how they were building bridges during crusades. He was a crusading spy. And so this coming from a mathematics educator is totally unacceptable. So the fucking fallacy is that you switch between two contradictory premises. One side you say formal math is superior, then you say, oh, they are the same. So the use value comes from normal math, the difficulty and the superiority comes from formal math. And because you are switching between contradictory premises, you can derive any pre-desired conclusion. We know that A and not A implies B, and B is any proposition. Okay, so ultimately, if you say Hardy, for example, would admit that formal math has no use value. But then the claim would be that it adds epistemic value, it adds rigor to your proof. When you give this complex proof, you get rigor. Okay, only Greeks use reason. So, well, we saw that already. I think I will skip that because basically the prohibition of facts is unique to formal math and to the church theology of reason adopted by church during the Crusades. And these two are compounded. So I should skip that. Just want to point out that there are no axiomatic proofs in the Euclid book or by any early Greeks. I gave a prize of some 2 lakh rupees. Everything I'm giving a prize. Nobody responds. So there's not a single axiomatic proof. It's been admitted by the West since more than 100 years. Russell wrote about it. Okay. The book was reinterpreted to align with the prevailing theology. It's not, there's no axiomatic proof there. First theorem, first proposition of the elements is empirically done. And it has to do with massesis, which is where I brought in the author as a black woman. So let me skip that one. The question I'm asking is, church prohibited facts because it serves its purpose, because it's dogma. Every dogma is contrary to facts. You're talking about heaven, hell, angels, and so on. And Aquinas, who proved an angel theorem, oh, I don't have a link. I have a very nice image of Aquinas, Summa Theologica. He said, you can fit any number of angels on a pin, but there are no facts about angels. So his reasoning could not begin from facts. So it began from a postulate or axiom. And the church thought that reasoning is more powerful than facts because God can create facts of choice, but cannot create any logical one. Okay, so I should skip this. There's also a question of which logic to use because quantum logic. Now, if you're going to talk of quantum computers, you have to use quantum logic, not two-valued logic. And it is just not the same. You can't just assume you have two-valued logic. It is not even three-valued. It is not quasi-truth functional logic. It's too much to go into that right now. So our concern is for math for science, not the church politics of reason. So the paradox is if you prohibit the empirical, how does math work for science, which accepts the empirical as a starting point? So deduction is valuable. I have again I gave a talk in Durban on that. I think I'm going to skip through this very rapidly. So the point that is made is that deduction is infallible. Why is it superior? Because empirical proof is fallible. True, everybody accepts it. You have experimental error in science, but reasoning is infallible. That is nonsense. And well, any math teacher knows that students turn in lots of wrong proofs. So if reasoning were infallible, they should always get the right proof. Even authorities like Riemann published wrong proof. How do you know that Russell's proof is infallible? Did anybody check it? Not even a typo in 378 pages. Is it worth checking? So you will not do it. You just go by trust. Now, the other point is that deduction is more fallible. See, both are fallible. Which is more fallible? You see a game of chess. Every human being almost always makes a mistake and loses to a machine. If you don't make a mistake, you can't lose. You must end in a draw. And deduction gives only relative truth. This is a very old critique by one school of philosophy in India which did not accept reason. And this is, look at the conclusions. Now let me give the Banach-Tarski theorem, which is that you can take one ball of gold and purely by using set theory, you can divide it into a finite number of pieces and reassemble it to get two balls of gold which are identical to the first. You can get rich quick, no problem. So I made this, simplified it in my rabbit theorem. So rabbit theorem says all animals have two horns. A rabbit is an animal, therefore a rabbit has two horns. So you can see that it is nonsense. The proof is valid, but the theorem is nonsense because it is relative. Theorems are relative truths relative to the axioms. And the axiom that all animals have two horns is wrong, but it is an axiom. You can only prove it wrong empirically. You can't prove the axioms of mathematics false empirically. There is no way to apply set theory, empirical proof to the axioms of set theory. All right. So anyway, point is that deductive proof is very unreliable, and it adds formal math, does not add any use value, does not add any epistemic value, adds political value, because for what valid axiom you should use, you have to ask the West. If I say I want to teach calculus without real numbers, you have to ask the West. But they control it. All right. So it gives power to the West to control mathematical knowledge. All right. So what was different about the Indian calculus? I am okay. I'm reasonably all right. So Aryabhat's method of finite differences was the same as that of Euler. So what he did was, well, let me go. There are three issues: finite difference method, Brahmagupta's non-Archimedean arithmetic, and zeroism or a philosophy of inexactitude. That's a summary. So finite differences were used, but no limits, so no derivatives. What is today called Euler's method, falsely called Euler's method. Euler had access to Indian texts. He wrote an article on the Indian calendar, but of course he made an independent rediscovery, like all Westerners do. So he derived a table of 24 sign values that showed you part of the, by solving a difference equation for sign, second order equation. Of course, they are not unique. So you'll say, what's the problem? How do I know? But you don't need uniqueness, because the aim of calculus is to numerically solve differential equations. All practical applications, well, most practical applications of calculus come from solution of differential equations. And in that, finite differences appear only at an intermediate state. Doesn't matter which finite difference scheme you use. So the point is that the objective of calculus is not to learn tricks to calculate symbolic derivatives and integrals. It's a worthless task which a computer program can do, but to solve differential equations. And so point I'm making is calculus without limits preserves, indeed enhances the skill of students to solve practical problems related to calculus. So I use my software calculator. I already showed you that. And of course, students can develop their own programs if they like. The second part, which is an important part, is which is the part which the West failed to understand. They understood the finite difference method, but they had a problem with exactitude. So they wanted an exact notion of derivative. Brahmagupta arithmetic is that you, let me recall this statement. Belief in witches is 1,000 times more possible than saying minus a less than 0. Now, what are we talking about here? We are talking about order in integers on the real line, which this fellow did not understand. All right, big professor from University College London did not understand. He says it is 1,000 times more possible to believe in witches. All right, so he did not understand ordering in integers. Therefore, it is natural that Europeans in Newton's time did not understand the ordering of polynomials. Brahmagupta started polynomials. He called it Avyak Ganit. So it's just like arithmetic. We're using an X. So West got its algebra from Al-Khwarizmi, who translated only a part of Brahmagupta. and did not consider the ordering. He was focused on linear equations, which he thought was the practical value. So polynomials are like integers. Okay. So in formal mathematical terminology, both polynomials and integers are an integral domain. You don't have zero divisors. They are also ordered integral domains. You have an ordering in integers, you have which De Morgan didn't understand. You have an ordering among polynomials. But the polynomial ordering is fundamentally different. So because you have an ordered integral domain, you can extend it to a field. I'm talking formal mathematics now. You can extend it to an ordered field of rational functions, just as you can extend integers to an ordered field of rationals. But rationals are small, rational functions are big, and they have a peculiar property that they are not. Well, this is a link goes to where I've done all this. I don't think I have enough time left. All right. So let me just explain the rest of it quickly. So the key point is that an field of rational functions is non-Archimedean. See, when you say a polynomial is positive, let us say x minus 3. Now, x minus 3 will be sometimes positive, sometimes negative, depending on the value of x. So you say it is positive when x minus 3, because it is positive for large values of x. So x minus n is positive because x minus n is positive for large values of x, no matter what n you choose. So in an Archimedean field, like the field of integers, you should be able to make any number less than n. You cannot do that in polynomials. Therefore, it's a non-Archimedean field, which is different from the arithmetic of reals, which is the largest Archimedean ordered field, by the way. So if you have an Archimedean, non-Archimedean field, you can't have epsilon delta limits. Why not? Because you take a limit becomes less than 1 by n, but you can always change it by an infinitesimal, and so you will get non-unique limits. So such a field has got infinities, and it's a field. So if you take 1 by an infinitesimal, you will get an infinitely large number. But of course, in calculus without limits, inexact limits are possible by discarding infinitesimals. So West understood this only in the 1960s in its usual ultra-complex way when non-standard analysis was brought in. I used it for my PhD thesis. Non-standard analysis, but in non-standard analysis, infinities and infinitesimals come in only at an intermediate state. They go out. The final result has to be standard. But in non-Archimedean arithmetic, they are permanent. They are there. But there's nothing funny about saying that x is greater than, unless you don't understand ordering. All right. So non-Archimedean arithmetic, and then the thing is that you can eventually discard, using zeroism, to discard infinitesimals. So that's the third pillar, which is zeroism. It's a philosophy of inexactitude. So there is a Western superstition that mathematics, we have a superstition that rigor comes from banning the empirical, but there is another superstition that math is exact. Now, okay, if you are doing pebble arithmetic, you talk of exactitude until you break the pebble. But the moment you come to even the Pythagorean calculation, I call it calculation, not theorem, because the problem is to calculate the diagonal of the given the sides of a rectangle, and the diagonal happens to be √2, so you can't calculate it exactly. You can't write it down exactly. So Indian traditional geometry accepted this inexactitude. In fact, the name for square root of 2 was Savishesh, with something remaining. But you handle this inexactitude in everyday life. No two dogs are the same, but you don't define a dog by giving the number of legs and so on. You just point to a dog, and children can figure out. In fact, the Buddhist philosophy of Shunyavad points out that there is no escape from inexactitude in real life. And you are not the same. From the time this lecture started, you breathed in, breathed out. There's so many molecules in your body have changed. Your thoughts have changed. So many things have changed. And those changes are just more visible over time, let us say from childhood to old age. So you can't have exactitude in real life. It's only a fantasy. Okay. So if you want math to have anything to do with reality, you should be able to manage inexactitude, handle inexactitude. So the contrasting European superstition of math as exact goes back to Plato. And the idea of Egyptian mystic geometry. So math has matrices. That is where the importance of black hypatia comes in. The Euclid book, actual book, not the myth about it. The actual book is on math and matrices. It has no axiomatic proofs. So that is Egyptian mystery geometry. Whole aim is to arouse the soul. And how do you arouse the soul? You drive the mind inwards. So, for example, in Indian Hatha Yoga, you shut out all external influences. Close your eyes, close your ears. Okay, and then you this is a pose, loaded pose. But then that is in Hatha Yoga, you can just concentrate. As in Raj Yoga, internal and meditation to drive your mind in. That's the whole idea. But the church suppressed pagan thoughts in the 4th century quite violently. And it changed the nature of soul. That's in the book that I've written. And therefore, this aspect of the nature of soul was lost. So therefore, during the European Dark Ages, they misunderstood matrices in terms of sympathetic magic. They said soul is eternal, math arouses the soul, therefore math must also have the eternal knowledge. That was the argument from sympathetic magic that Europeans gave. It's a wrong argument. But since it is eternal knowledge, it must be exact, because whatever minor discrepancy you have, it will be exposed in an eternity of time. That was the simplistic argument. But then, because they were long accustomed to the belief in math as exact, they clung to the fantasy of exactitude. And therefore, you do infinite sums exactly by using metaphysics, by using a fantasy. I can do the infinite sum in metaphysically, not in reality. And there it is metaphysically exact. But exactitude can never be obtained in reality, so it has no practical relevance. Always in scientific experiments, you have experimental error. So with these two features of arithmetic and Brahmagupta arithmetic and zeroism, you can obtain inexact limits quite easily. Instead of saying limit as n tends to infinity, 1 by n equal to 0, you just say when n is infinite, 1 by n is infinitesimal and can be discarded and replaced by it. So you can also sum an infinite geometric series. So if you do this simple algebra, 1 minus x into 1 plus x plus and so on up to x raised to n, it's 1 minus x raised to n plus 1. It's very easy. Just cancels the alternative terms. And then you say, therefore, that this sum is this ratio, it's this rational function, 1 minus x raised to n plus 1 by 1 minus x. And then you say if x is less than 1, then when n is infinite, x raised to n plus 1 is infinitesimal, so discard it. No real numbers, no set theory, nothing. And so that's the simple way in which one can do things. So calculus without limits makes it easy, gives better practical value through numerical solution of differential equations, which includes non-elementary functions. It's an immensely simplified understanding using Brahmagupta arithmetic or non-Archimedean arithmetic instead of formal real numbers, which you understand. It is realistic. Everyday philosophy of zeroism instead of false claim of exactitude. All right. So for those who are emotionally attached to the foolish Western idea of teaching calculus as about calculations of derivatives and integrals, as a soap, I teach maxima. Earlier it was called maxima. It was a Defense Department secret. I was the first to import that package in India. Very expensive, some 20,000 pounds, and then the machine became defunct. So anyway, point is that what is the relevance of science? Further relevance, do harder problems. So let us look at the partial differential equations of physics, or any differential equation for that matter. The fact is that it will fail at a discontinuity. So discontinuities arise in practice, and then what do? Those struck waves and singularities and so on. So on the college calculus definition of derivative as a limit, a differentiable function must be continuous. So therefore, a discontinuous function cannot be differentiated. But you need to differentiate. Shock wave, you have a cracker blast or explosion, the black blast wave, which creates a hypersurface of discontinuity across which variables such as pressure, density vary sharply. Sharply meaning they vary across a distance of a mean free path. And pressure, etc., are statistical averages. And they are not defined. Such an average is not defined on such as short length because it's different on both sides. So what happens to the equations of physics? When you encounter a discontinuity like this, do they fail? what do you do? So there are many definitions of the derivative which permit the discontinuous function to be differentiated. So Sobolev, Mikusinski, Schwartz, Delphin, and Shilov. But since you go by Western social consensus, you have only Schwartz. My spell checker only understands Schwartz, doesn't understand Sobolev and so on. So the point is that if you do accept the Schwartz derivative, whether on social consensus or whatever, it is not a generalization of the. I want to go to a presentation mode here. Present. Okay. All right. There was a set of what has happened today. Okay, let me scroll. I'll just give it to you quickly. I had a link, but I can't see the link. Okay, so even if you have possibly, because Heaviside function, for example, is just the Heaviside function, 0 if x less than 0, 1 if x greater than 0. And it is not defined at x equal to 0, doesn't matter. Its derivative is the Dirac delta function. But its derivative almost everywhere is 0. It is constant on either side. So, well, I just went through that. Point is that Schwartz theory interprets it in a very complex way. And you have different definitions of the, let me come to space of text functions, a horribly complex topology, which can't go. This is the question I'm looking at. So, which definition of the derivative do you use? Do I use the Schwartz definition or do I use the ordinary definition, epsilon delta definition? Both can't go together. All right. So what do you do? So delta, this function is not the zero distribution. And then there is the other problem that you have, that the differential equations of physics are nonlinear. And once you differentiate a Heaviside function, then you get a delta function. You have to multiply them. So you can't multiply them. This is I don't want to go into too much detail. This is quite difficult stuff. Yeah, this is the kind of, I think I have a slide on that. I'll come back to that. So if this is theta, use the Heaviside function. Since it's 0 and 1, its square is itself. And if you differentiate it and apply the so-called Leibniz rule, you will get twice theta into theta prime is theta prime. But since, so theta into delta is half delta. This is in Cobb, Journal of Mathematical Physics. But then you also have theta cube equal to theta. And you apply the same logic. But since theta square is equal to theta, you get half equal to 1/3. So that is what I call Tobb's folly. All right, let me get back to my presentation. So you don't know which definition of the derivative to use. And this I just explained, half equal to 1/3. And apparently, West did not learn to use fractions properly, even now. Okay, so calculus, I solved this problem first using non-standard, that was in my PhD thesis, using non-standard analysis applied to Schwartz distributions. And I have new conditions of shock waves. I can't possibly describe it. Just I'll flash the transparency at you, slide at you. These are the conditions in general relativity. These are the conditions for range shocks. And you can see the details are there in my book and the references that it cites. I want to go to my last topic. I am doing all right. I'm a little over time. So, because there is such a difficulty here, there's a politics which gets into singularity theory, which I want to talk about. Shocks and singularities are similar. That differentiability fails. What do you do? So you can change calculus or you can change physics. But Stephen Hawking, in a serious book, which is the serious book? This is the one, Large Scale Structure of Space-Time, which he wrote with J.F.R. Ellis. he linked it to God and creation. The last line of the book is that the actual point of creation, the singularity, is outside the presently known laws of physics. All right. So this is what he does. It's not calculus which fails, it's not physics which fails, it is something about God and creation. So this is made quite explicit in his popular book. At the Big Bang and other singularities, all laws are broken down. So God would still have had complete freedom to create, to choose what happened and how to what world to create. All right. So it must be a moment of creation. That's what a singularity is, not a mathematical problem, but a theological problem. So this is made much more bluntly. Tipler is a very blunt fellow. So he put it very bluntly. He said theology is the branch of physics. And I'll skip through this. Central claims of Judeo-Christian theology are in fact true. And they are straightforward deductions of the laws of physics as we now understand them. And I have learned this from Penrose and Hawking, singularity theory of Penrose and Hawking. That's his branch of relativity that he says. He's written papers in Nature on that. And he's written several books on that. Not just a remark. I mean, this remark is from that book. So, physics of immortality. See, it's where we have gone from calculus, modern cosmology, God and the resurrection of the dead. So he's talking about when will the dead be revived, will the dead be raised, why will the dead be raised, etc. and so on and so forth. And he publishes in Nature, he says, I have so many papers in Nature, you better believe what I say on the authority. So I raised this issue, I had a debate with Roger Penrose on singularity theory in 97. Penrose was evasive. I published a lot. There is a paper on distribution matter tensors, what happens when your continuity breaks down. There is a whole book, 11 pictures of time on the physics, philosophy, and politics of time beliefs. Right? And the central point in the book is then the articles in newspapers. You just need to look at this, Christian propaganda and Stephen Hawking's work. A long form article after Penrose got the Nobel Prize recently. So there's an article on that. It is called Singular Nobel. So it is, you can take a look at this. I can't just discuss it offhand. Each thing will take hours to discuss. So this was the point. See, my quarrel was with Hawking and Penrose, Stephen Hawking and Roger Penrose. Ellis was just a sidekick until I came to University of Cape Town, where he was the top dog in the math department. He got the $1 million Templeton Award for putting together science and religion. So the point I'm making is that mathematicians can put in any kind of prejudice into science through formal mathematics. They have no control. And they have the control. It has nothing to do really with science, but how do you say that? You say that, then this is what happens. Because I offered to discuss this in the math department, I didn't realize. So that is why Ellis was frightened to death, and to protect his $1 million scam, he started the conspiracy theory scam along with the local church. So the moral is, if you trust a formal mathematician, there are many, I don't say all, there are many willing to fool you in a variety of ways, some of them excessively foolish, but they work in some sense. Okay, so Europeans stole the calculus, they failed to understand it, they developed an impossibly difficult and scientifically useless, but politically powerful way to understand it. Boasted that it is superior, globalized it through colonial education. The original Indian calculus is far easier, it improves science teaching, but West and the mathematicians subordinate to it because they have the money, will not allow its teaching even on a trial basis. But I hope that you are able to do this in South Africa. That's why I am talking to you for so long, because West is afraid to lose space and to lose control over its mathematics if all these things come out. So postscript is that even to try the alternative, you need a revolutionary change. You have to stand up and fight. You have to revolt. And I'm suggesting that you need a few things. You need to laugh, you need to try, you need to challenge, and you need to beware. So laugh, I've shown you about European backwardness in math, even in arithmetic. And you keep quoting it what mathematics could dead white men have created without knowledge of fractions. And the proof is Gregorian calendar, reform of 1582. Step 2 is try, please try to teach. If you don't like it, you can reject it later, but at least try to teach calculus as normal math. As I've explained, it has been tried in so many places. So West has always lied that colonialism was for the benefit of the colonized. They steal your diamonds, they steal the wealth, stole all the diamonds in Kimberley, reduced India from a wealthy country to a poor country, slaughtered 100 million in India, apart from what they did in America, and said it's all for your good, our good, not theirs. So don't trust the West. Try it yourself. It should be your knowledge. And it now teaches formal mathematics, saying it will improve in understanding, only increases the power. Because you hammer on the fact that real numbers are no good, not needed, and not taught. All right? You are never properly taught. So if you don't even try something different, you will forever remain Western into stage. And if you don't like what you teach, you can change it afterwards. So the third thing is you have to challenge brazen lies, like the Euclid book has axiomatic proofs, or that such proofs are invented, and also challenge propagandist obstructions, which are used to mislead people. And you should understand that the West is afraid. Nature wrote an editorial that there is nothing to fear in decolonization of math because there is something to fear. And they hope to mislead and misguide the decolonization effort that are on by saying you should decolonize like this, you should decolonize like that. This is coming from such and such big university, this is coming in Nature, etc. Now in 2012, Mullah and Combe asked me, what is there to decolonize in math? That time nobody knew decolonization of math. Isn't 1 + 1 = 2? And there is a similar question that was asked to me in South Africa in 2016. So now you throw my Cape Town challenge at them. Prove 1 + 1 = in real numbers, 1 + 1 = 2 from first principles. Otherwise, stop talking of real numbers. And beware of these sophisticated tricks like the fucking fallacy. Always ask, say, math works. Which math works? Normal math or formal math? How can NASA use computers to calculate rocket trajectory when the computer cannot use real numbers? And if normal math is what works, why then not teach normal math? That's the thank you very much. I'm sorry I took so much time, and I want to stop sharing. Yes, please. So thank you very much. Now I can take questions. I think I have about half an hour for questions.
Okay, thank you very much. Good afternoon, colleagues. My name is Percy Siping.
1 minute.
Also...
Just let me put on headphones. I can't hear you.
Okay, I'll wait, Prof.
Just give me a minute. It's not switching on. Okay, go ahead.
Thank you very much. Thank you very much for the presentation. Really, this is an exceptional, words from us, especially looking at the historical background of South Africa. But then also the,
you are not audible. You are not audible.
Okay, let me switch off my video. Maybe the network is a bit slow. Can you hear me now, Prof?
Yes.
Oh, perfect. I think I've switched off my video now so that the network can be much better. No, I was saying, Prof, thank you very much for the insightful and very, intelligent kind of presentation that you gave to us. We really excited about this, but then also it challenges, our thoughts as Africans, but then also in particular as South Africans, in terms of challenging what we have been fed by those colonizers in the West. I think we're still doing well in terms of time, colleagues. We have approximately 22 minutes according to my clock. And I think now is the time for us to have that exciting Q&A session where we want to also challenge Professor Raj in terms of what he has given us, but then also contribute meaningfully to his presentation, but then also for further clarity-seeking questions. Now, I'm inviting your colleagues to start with your questions or comments as far as this particular presentation is concerned. The floor is open. I see. Let me just do this. I see Dr. Vanessa. I saw your hand. Please go ahead.
I do not have a question. I just want to commend our presenter for the absolutely deep and impressive work and contribution to knowledge. I just want to say thank you and to thank the School of Education for this. That's all. Thanks.
Okay, thank you very much, Dr. Vanessa. I think those have, delivered to Prof. I see another hand, Dipen. Please go ahead.
Hello.
Yeah.
Yes, we can hear you. Go ahead.
Hello, Professor. My question is about the proof.
Yes.
Professor, you had said that deductive proof means the Western mathematicians, they divorce empirical from deductive proof. Means they divorce empirical from mathematics and just said that deductive proof is the most superior kind of proof, right?
Not quite. What I said was that deductive proof is used by everybody, but what the West did was use axiomatic proof. Let us discriminate between axiomatic and deductive. So axiomatic proof is proof which prohibits facts to begin from axioms and not from observations or facts. That clear?
Okay, and axioms can be, and axioms are like similar to Bible. That Bible is true, so axioms are true.
No. Axioms are purely fantasy. They are metaphysics. Supposing you take a simple axiom that there are an infinity of points on a line, or the line. This is there in class 6 text, school text.
Yes.
Line extends infinitely on both directions. How do you know that? How do you know that there can be even a straight line, or that a straight line can extend infinitely? How big is the cosmos? You don't know. So those are metaphysics. Because the line is not visible, you cannot know what it does. It is not your knowledge. You have to believe whatever is stated because it's all about a fantasy world. All right. So axioms are fantasies, and that fantasy is controlled by the West.
Okay. So yes. So my question is that, like, when I was in class 12th. So my teacher has demonstrated the need for this proof actually. Means how to generalize. How to generalize.
Can I interrupt you? I have a
Yes.
video on that. There is the lie that is stated in the text is that others did not have any means of proof. I showed you the quotation from Nyaya Sutra. There is a whole video based on that. And if you see the Bangalore video on Euclidean geometry versus Rajju Ganit, you'll find it there. It's also a separate video. So there was a system of proof, but the difference was that proof began with facts like science. But you are beginning proof from axioms, which cannot be empirically verified. You have to accept an authority. Only Shabda Praman for that. So the issue is, why should we accept the axiom? Because the axioms could be wrong. I gave an example of Banach-Tarski theorem, or a simpler example of rabbit theorem. All animals have two horns. You laugh. They don't have, but you can see actually. But said theory you cannot see. I say axiom of choice. How do you know it is right or wrong? Because it's about an infinite set. You cannot test it. I say it's used all the time. Zorn's lemma, Hausdorff maximality. So you have no way of testing it. You have to accept it because this is socially accepted. It's accepted in the West, so you also use it. So let's be clear. It's not about proof. That is a wrong, false rhetoric. It is about a particular type of proof which prohibits facts, which goes from what the West says. So please read that up, and then we can discuss it. All right.
Yes, Professor, but I had my question about generalization. Like, I wanted to give an example. Like, my teacher demonstrated why deductive proof is important. She was demonstrating about mathematical induction. She gave an equation in the form of k. Now I don't remember what that equation was, but she then said that is this equation true for all the integers, all the natural numbers, sorry. And she said that there is a way to prove this, like k equal to 1 is true, and when k is true, then k plus 1 is true. So I think means you know that, right? So
Yes.
she gave an example where we put the values and it was true till 41 and k equal to 41. Like
See, the
she
issue
said
is
that.
not deduction. Please get it straight. Issue is not about
Okay.
use of deduction. Use of deduction is accepted. I just said that. Issue is where you
Yes,
start.
yes.
And if you're starting from some premise which is not empirically testable, then you have a problem. So go from natural numbers to real numbers. Now you tell me
Yes.
what your axiomatic proof is. Give me an axiomatic proof of 1 plus 1 equal to 2 in real numbers.
Yeah, I cannot. Matlab,
So that is the problem.
Yes,
Okay.
that is the problem. I understand.
Okay, thank you very much, Daipen. If you may also share with us where are you coming from, your affiliation?
Huh? Hello? Sorry.
Yeah, if you can just give us your affiliation in terms of where are you from, where are you working at now?
Actually, I used to read the blogs of Professor, and it helped me understand. It helped me academically, actually, because I used to believe that mathematics is perfect, but learning calculus, actually, it is like contradictory things. Those are contradictory things. So when I used to watch his blogs, used to read his blogs, and I watched his videos, and he said that mathematics is not perfect. So it helped me. So that is why I'm joining here.
Oh,
I'm
thank you
just
very much. Thank you very much, Daipen. Colleagues, I'm going to request that when you ask your question, let us try to be brief. Daipen, if you can mute your mic, please.
Yes.
Thank you very much. I've got from the chat box, Professor Raju, there's a comment and perhaps slightly a question. It says, Professor Raju, I'm an engineer and a father of 14-year-old son who is studying in 9th grade. I've been teaching these facts. You have been showing your talks without even being able to show him the actual maths works in it. Now, since it is important these facts should go to a larger crowd, how can we as parents help our kids to learn Ganitha, since everyone will get opportunity to learn from you in person? Do you want to respond, Prof?
Yeah, certainly. I would like to say that there is a textbook available, there's a teaching manual available, there are videos available, and this is also string geometry is part of the African tradition. You saw the front page of that. So basically, the moment you say a point is invisible, then you are saying it's not your knowledge. Whatever points do is something that somebody will tell you, that between 2 points, there is a unique straight line. That's the axiom. But if you have real points, if you're making a real dot or marking it in some way, you can always connect it with more than one line. So the axiom is false, but it does not matter, because if you're making a measurement, the slight change is something which you can neglect. So I think that the critical thing that you have to warn children about is not to accept statements about things which they do not have their own personal knowledge about, which they cannot have, about invisible points and invisible lines and invisible planes and infinity and so on. So they have to be careful about that. They should be suspicious, they should be skeptical, and they should ask, how do you know? How do you know that this axiom is true? And who says so? And why should I believe it? And how does it help me? How does it help me in practice to work with invisible points? If I have to measure something, I'm going to measure it by making visible points. So I think that these are the questions that you have to ask. And there is a whole program. So it will be great if you start this in South Africa. I can come once if you like, and I can explain. The whole course is there. You can take the course. There's a teacher's manual also. There's a textbook also. So you can certainly start teaching it if there are other people interested. And we are doing this now even at a primary school level. We're extending this. The calculus is higher up, but the point is at school level, it is difficult. Because if you teach this, and if you also teach this, student also has to learn what is taught in school, the two things are contradictory.
Okay, thank you very much. Yeah, thank you very much for the response, Prof. I see another hand. Can we have Chakrada? Your name and your affiliation, please, and your question or comment.
Yes, thank you. I'm based in Mumbai. I'm known to the professor. I have loose affiliations with Sociology Institute in New York City and governance think tank in Berlin. My question is related to my own experience of doing mathematics as a kid. When I used to be prompted with small clues and left by myself, and I would discover a lot of things by myself. Somewhere I seem to have suddenly lost that facility to play with mathematics. And I'm curious about maybe is this this complexification that the Western mathematics has brought about, is it in such a way that you're losing your own agency to discover it or to simply understand it? Is there am I able to explain my quandary? Because
you have lost the ability. You have lost
Yes.
the ability to either explain or understand even 1 + 1 = 2. I gave
Right.
that explicit example. So you have lost it, and you have to play the game of ask a mathematician. And which is the mathematician who's reliable? Is the Western mathematician who's reliable. Don't ask a brown-skinned chap.
Yeah, okay, that makes sense, because basically you lose your own power to do things.
Absolutely, absolutely.
So so as a corollary to that, when I finished my PhD in engineering, I enrolled in a PhD in mathematics at the University of Houston. The strange thing was there wasn't a book of mathematics I could not understand, but I still could not do mathematics. I would do advanced group theory, I would do topology, I would do number theory. Anything anybody would explain to me, would show me, I would understand, but I couldn't think of doing anything new. And I'm wondering, is it because that nothing, I mean, it wasn't evident to me of what could be easily evidenced or easily demonstrated, or I don't know what I was losing there.
Well, I suppose that as an engineer, you have a practically oriented bent of mind, and you might have wondered how you are going to use it. And the point is, you can't use formal mathematics. That's the whole point I'm making. So it's useless, and so you abandoned it.
Thank you so much,
Used
Dr.
for all kinds of crooked purposes. But not for
Thank you so much.
purposes of application to technology.
Okay, thank you very much, Katrada, and thanks, Prof, for the response. I've got another comment, Prof, here from the chat. It says, thank you very much for this. I think it's from Polani. Thank you very much for this amazing presentation, Prof. Raju. I admire how you linked it to Africanism and decolonization within the teaching of the most feared subject, which is mathematics. Your presentation really reminded me of the late Professor Neville Alexandra, who advocated for the importance of a mother tongue-based bilingual medium pedagogy in the teaching and learning of mathematics. The second one, before I go to, okay, I see a hand. Let me go to Madimabe. I think Makosi, all the way from Summerstrand campus, South Africa. I think it's my alma mater, Nelson Mandela University. Over to you, Madimabe.
Oh, thank you very much, Prof. Sibeng. Thank you, Prof. Raju. I really enjoyed, this is not a question, it's a comment. I enjoyed the presentation, and I also admired how you critique maths. It was quite a pleasant presentation to sit in. What I also liked about the presentation is the fact that it managed to take me back to the reason why I enrolled into the PhD qualification that I'm busy working on joining the advocacy of preaching the importance of teaching normal maths, where we go back to the basics. We encourage teachers to try and teach differently. We want to establish the knowledge balance, being aware of the troubling constraints that are experienced in maths currently. So Nelson Mandela, Sol Plaatje University, thank you very much for the arrangement of this presentation. It has really given one quite a moment to sit back, think about things, and yeah, it was insightful. Thank you.
Okay, thank you very much.
The question about language. Can I answer the question about language?
Yes, yes, Prof, go ahead.
About mother tongue, I completely agree with you about the use of mother tongue. I fully agree with that. But the point is that if the concept is foreign to the mother tongue, then things become extremely complex. Now, my mother tongue is Hindi, but if I try to read mathematics texts in Hindi, because they take a concept which is foreign to it and distort it. Simple concept of angle. Now, angle is defined as two straight lines in the text. That's not how I define it. Defined as two straight lines in the text meeting at a common point. And that common point, apparently, because there is no corresponding concept in Hindi, that does not mean there was no corresponding concept of angle. Concept of angle in string geometry is that it is the relative length of an arc, of a curved line, nothing to do with straight line. So relative length of a circular arc, and then the usual angle that you call it, if you take the two ends of the circular arc and join it to the center of the circle, that is what it is. Now, if you take a foreign concept and then try to translate it, it adds a second layer of complexity. So you have to do not only that, you have to do it, you have to change the concepts, not merely the language. Then it will come out naturally.
Okay, thank you very much for that brief response, Prof. I've got another comment from one of the participants, and it's from Mr. Edward Matabane, Sol Plaatje University. My background is in point-free topology, and I can relate to the torture of the Western logic in mathematical proofs. In your talk, you spoke about difficulty in mathematics as a source of power for the West and a mental slavery. One needed to trust the slave master using 378 pages to prove simple results that 1 + 1 = 2. My question is whether the material on teaching calculus without limits is available for us to use. Perhaps my students will now enjoy calculus to be less torturing.
Certainly it is available. You start a course, it is available. It's available to anybody who starts a regular course. Because the lectures are all there, material is there. There is no text, because the text depends upon which students you are teaching. Whether you are teaching undergraduate students or postgraduate students or social science students or who. So depending upon that, because there are sections for each one of them. So it is definitely available. Rest assured, it's available. I've just taken it off the net because I got, there were all sorts of mischief makers doing various things. So I will make it available to you the moment you start a course. I'll be very happy to make it available.
Okay, thank you very much. I think we have almost 3 minutes. I've got two last, a comment and a question. One is from Kathrada saying, Chakrada, I meant, should we not redefine what needs to be taught in K-12 education curriculum? I am supporting a school in rural Nigeria that's struggling with figuring this out. Any ideas, Prof?
Yeah, we are redefining because we are doing this in a school in Kolkata. Basically, the difficulties of mathematics were introduced by Europeans. For example, negative numbers, something which people find difficult. And so you teach them differently, or large numbers and so on. So the syllabus is there. So we are trying to redefine, but then that is not tried and tested so far. We will be trying it from in a couple of months, but it will take some time. It will take about a year or so. You can also join the trials. Welcome to join.
Okay.
Yeah,
thank you so much.
Question? Yeah.
Okay, thanks. I think the last question, hello, Prof. Raju. I think it's from Devendra. I'm an electrical engineer in Australia. Your work and books are phenomenal, and need to be spread to common people far and wide in India. We would like to make a film on this subject produced between India and Australia. We have a team of filmmakers with us. Would you kindly like to be part of it in the capacity of a guide or intellectual guide? If yes, let us know how to contact you for this purpose.
Sure. You contact me, then I can let you know, because I don't know how to contact you. You'll have to send me an email or something like that. You can get my email from anywhere. So you contact me and I'll be happy to help out. Yeah. I'll put in
okay, thanks, Professor Raju.
Yeah.
Okay, thank you very much. Prof, any final words from yourself, Prof. Raju?
Yeah, I would just like to make one statement that I keep giving lectures, but what I would love to see is action. And therefore, I was very happy with the title suggested, A Revolutionary Change, because revolution is about action, not just about hearing lectures, trying it out. So please try it out. And that would be something that I can help in whatever way possible. I would like to help. So thank you very much for patiently listening, but do try it out, because decolonization is about action. It's not about writing papers and so on. Thank you very much.
Thanks. Before we go away, I think I've been requested to do a vote of thanks. It's a pity, Prof, you are a bit far away, but with technology, you are very, very close to us. And I think Mr. Matabane and the school would really facilitate a token of appreciation to you that will also be wired through to India, so that you can also think of us as Sol Plaatje University, but then in particular South Africa. So, ladies and gentlemen, distinguished guests, faculty members, students who are here with us, we're talking about participants from all over the world. Thank you very much for really joining us. Indeed, Prof. Raju, you are not a historian of mathematics, but a revolutionary mathematician par excellence. This is something that we have to take away with. Now, today we gather to express our deepest gratitude for an enlightening seminar on revolutionizing education that is transforming the teaching and learning of mathematics and science for the 21st century. As we reflect on the transformative event, let us also take a moment to acknowledge the remarkable history of Sol Plaatje University, our esteemed institution of higher learning. Now, Sol Plaatje University, established in 2014 in Kimberley, South Africa, holds a special place in the landscape of education, not only in South Africa, but in Africa, as well as across the globe. Named in honor of Solomon Tshekisho Plaatje, an influential South African intellectual, writer, and political activist, the university embodies his commitment to social justice and equality. From its inception, Sol Plaatje University has been dedicated to providing quality education that nurtures critical thinking, innovation, and social responsibility. Today's seminar, led by the esteemed Professor Raju of the Institute of Education in India, aligns perfectly with Sol Plaatje University's vision. Now, Prof. Raju's profound knowledge, expertise, and passion for transforming education have enlightened us on the challenges and opportunities of modern-day education, specifically in mathematics and STEM, as well as STEM education. We are truly grateful for the innovative approaches shared, Prof, which empower us to create a stimulating as well as an inclusive learning environment. Now, the success of this seminar would not have been possible without the tireless efforts of the School of Education and the organizing committee under the leadership of the acting head of school, Professor Amasa, in his absentia, but then also our progressive head of department, Dr. Boats, but led and coordinated with the intelligent network that Mr. Matabane has made with you, Prof. Raji, so that in the end, you can come and give this exciting, but then also enlightening seminar. But then we also extend our heartfelt appreciation to all the colleagues for their vision and dedication in providing us with enriching opportunities. By virtually bringing Professor Raju to our campus, they have showcased their commitment to our professional development as academics, as staff, but then also educational growth for our students. Furthermore, we express our sincere gratitude to the Sol Plaatje University Executive Management under the leadership of the university's principal and Vice Chancellor, Professor Kroch, the support and assistance of the IT department, the strategic role and support of the research office under the caretakership of Dr. Musia, but then also the senior management committee team of the School of Education. I've seen our departmental heads who are still here with us. We deeply appreciate that. But then also the faculty members and staff who worked diligently behind the scenes to ensure the smooth operation of this particular seminar. A special thanks also goes to the support staff of the school who worked tirelessly behind the scenes. Now, we would also like to acknowledge and thank all participants, both local and international guests from all over the world, in particular, India, the USA, as well as Australia, who made this seminar a vibrant and interactive gathering. Your active engagement, insightful questions, as well as shared experience enriched our collective knowledge. Together, we have laid the foundation for a future where education in mathematics and science is transformative, empowering our students to thrive in a rapidly evolving world. Now, as we express our deepest appreciation to you, Professor Raju, for your exceptional presentation and the impact it has made on all of us, let us also celebrate the inspiring journey of Sol Plaatje University. This seminar, with its emphasis on revolutionizing education, echoes the university's commitment to innovation and the holistic development of our learners. Now, in conclusion, our gratitude goes no bounds. Gratitude knows no bounds, as well as extending our thanks to you, Professor Raju, the School of Education, as well as organizers. Let us forge ahead together, creating an education system that equips our students with the skills, knowledge, and values needed to shape our brighter future. Thank you all, and may Sol Plaatje University continue to inspire generations and generations to come. Thank you and have a wonderful day ahead. Thank you, colleagues.
Thank you, colleagues. Thank you, Prof.